Okay guys, I'm going to run through the mathematics for electrostatics real quick. Let's go over some of the quest problems. They're very similar to this. You need to be able to show the work because you're going to have to do this, right? So let's go through and underline, label. Let me show you how to do the G for guess for anybody that's new. The two electrons of a proton are separated by 1.4 times 10 to the negative 10th. Remember that this part right here in the calculator can just be typed in with that second. Then you type in those double capital E's that are blue. And negative 10, right? So the way you would actually type this in the calculator, 1.4 e negative 10. Sorry about that, that's kind of nasty. 1.4 e negative 10, and that's how you would type that in. The typical size of an atom, right? So we're talking about the atoms circling around the nucleus. What is the force between them, right? And we know that this is a repulsive force because they're electrons. Electrons have a negative charge. So they're going to have the exact same. But we don't need to worry about that for this problem, okay? All right. The Coulomb constant, so this is the K. Coulomb constant, K, is 9e9. That's how you would type that out, 9e9 newtons per meter squared per coulomb squared. All right, here's the answer just to make sure we got the right one. Now here's some constants that we need. Okay, so this was given to us in the problem. That's the K constant. But we also need to know that an electron always has a charge of this. Actually, it's negative, but for this problem, we're just going to keep it as an absolute value. A proton would always be a positive version of this, right? But the electron would normally be negative. All right, so we're looking for the force, right? So make sure you identify your unknown. What is the force? So force equals question mark, right? That's what we're looking for. Now, what force equation are we going to be using? We're going to be using the electrical force, right? So force electric is Coulomb's law. K constant times Q1, so that Q1 is charge 1, times Q2, which is charge 2, over the distance or radius between them squared, right? Now, what's important to note here is that since Q1 and Q2 are both electrons, we know that Q1 is equal to Q2, right? So we can, what's X times X? This is X squared, right? So because you multiply the same thing by itself twice, you get a square, we can simply, in the calculator, just simplify this to KQ squared over distance squared, right? So that's just a quick way to do that if and only if these are the exact same thing. So you make sure you know that, you star that idea, okay? So let's go ahead and plug in. So we get 2 points in our problem for underlining and labeling the correct things, right? So this is our distance. We looked for our unknown, which gets this point, and then we also have the constant. We have the constant. And also you want to list these guys out here. This is Q1, Q2, right? You can use this video for the quiz and write these in if you're doing electrons. Okay, so let's go ahead and substitute in force electric is equal to, what's the K constant? 9e9, the parentheses here. And what is our Q? Times 1.602 e, remember to just make it e, negative 19. It's a very small number, right? And we are going to square this bad boy, right? So you could either caret it in the calculator or you can put another parenthesis here and square it. Make sure to close that parenthesis. Then we're going to divide by our distance squared, right? So I would usually put a parenthesis around this just in case. So what is our distance? 1.7, oh, that's not good. Sorry about that. 1.4 e negative 10. For showing this step, you get a point. For showing this step, the substitution, you get another point, right? So it's actually, now we're up to 3 points. So notice we're at 3 points, and we haven't even done mathematics, right? That's very important. 4 points for plugging in. Anybody could plug in numbers, right? And where did you figure out where to put the numbers from? From your labeling, right? So you've done all the hard work just by labeling. And then part 5 is just the answer with the correct unit. If you're solving for force, it's newtons. If you're solving for charge, it has to be some value in coulombs. The distance between the two would be some number with meters, right? So make sure you convert to meters. And do we have any other ones? We won't be solving for the constant, okay? All right, let's go down here. If you double the distance, so when I think double, what do you do to a number? This is times 2. The distance, so that's d, between two charged particles, by what factor is the electric force affected? So we're looking for the force multiplier is equal to what? Here's the answer, 0.25 or 1/4. Let's look at how that actually works. Okay, so when you're doing a problem like this is called proportional analysis. Again, you work it out the same way. 1, 2 points right here just for labeling and listing your givens and unknowns. So here we go. So then we're looking for force, so we write the equation for force electric. KQ over distance squared. Which one of these did we affect? we are affecting the distance. So this is where our multiplier is going to get plugged into. This 2 is plugged into here. And since we're not changing anything else, it gets to remain as a 1, right? So Q didn't change, so it's going to be multiplied by 1, right? Because 1 doesn't change a value, right? 1 times anything is still itself. None of the charges change, so 1 times 1. And the distance did change by a factor of 2. We plug in our multiplier here, and since the distance is squared, we're going to square the distance here when we plug it in. So across the top, we end up with just 1. If you didn't trust me, though, you could always put this in the calculator, and you will get the right answer, hopefully. 2 squared is 4, and look at that, we get 1 over 4. So what does this value mean? It is 1/4 the force of the original situation. Neat, right? Get down here, I'm just going to show you how to quickly set this guy up. So you got hanging charges. I give you an angle. This is the angle here. It's also the angle here, right? What force is pointing downward? Well, on a mass, what pulls downward towards the center mass of the planet or the body you're on? This is force gravitational. What is the force that's causing these charges to get pushed apart? This is force electric, right? So in a triangle, this is the 2 legs, right? The 2 legs. So remember we had so, ka, toa, right? Which one of these functions deals with just the legs? The tangent, right? The tangent. Okay, so we're going to be using the tangent of this function, right? So look at this triangle. This is the force gravitational here. The force electric is pointing this way still, right? So we have the adjacent leg to 4 degrees and the opposite leg of 4 degrees, right? And that's going to help us do all of our mathematics. Okay, the magnitude of charge of each sphere. We're looking for the find the magnitude of charge in each sphere. So we're looking for the Q, right? And since these are both identical, guess what? Q1 is equal to Q2. So we can make this a Q squared, just like in the problem above, right? Okay. This is gravity, little g, not big G, but little g. And Coulomb's constant is this. So this is going to be, we can use 9 for the quiz today. It's going to be Q constant. All right. So how would we set this up? Well, we need to figure this out. Since we don't have enough information, we don't have the distance, right? There are a couple ways we could do this. We could find the distance, or we could find the force gravitational, right? So we have the force gravitational. Here's why we would want that, right? So if we have the force gravitational, it's known downward part, and we have an angle, guess what? We can just use the tangent to figure it out, right? Okay. Now let's see. So force gravitational is mass times gravity. We do have the mass and we do have gravity, right? So we would plug in the mass, 0.02, and then times 9.8, and that'll get us that answer, right? Okay. Now what I'm going to do is, since now I have that triangle like this, I have the force gravitational. And I'm looking for the force electric, right? This is going to be, this is 4 degrees. At that angle, right here, if I'm standing right here as a blue person, which 2 legs am I interested in? The opposite and the adjacent, so that's going to be a tangent function. The tangent of 4 degrees is opposite, which is force electric, over adjacent, which is force gravitational, which I have already, right? Okay, so from there, we're solving for force electric. So you would do that by rearranging and moving force gravitational to the other side. So you take your force gravitational and tangent of 4 degrees, and make sure you are in degrees in your calculator. If you're in radians, you end up with messed up stuff. You end up with your force electric, right? So now that you have your force electric, so after this step, so we did drawing out over here, underlining, labeling, all that good stuff. 2, figure out all your forces necessary. Draw a little picture, solve for the force electric here. And then 4, let's solve for the missing parts, right? So force electric is equal to K. Q we're going to do squared because they're the same charge over the distance squared. Now we need to solve for what? What was the problem asking for? Q squared, right? So let's go ahead and do that. Let's move distance to the other side by multiplication. So now we have distance squared, force electric equals constant times Q squared. Divide by the Q constant. It's all just algebra, right? This is not really physics we're talking about here. This is just algebra. It's just a tool. You're a tool. times q squared, and then we're going to, at last, what do we do with the square to get rid of it? We do the square root, and that's how you do this problem. All right, good luck.